Hello everyone, welcome to my YouTube channel Know About Embedded Systems. So in today's video, we will learn the CAN protocol and its registers. What are the different registers available in a CAN protocol and how to program them, we will understand. So before entering into the actual video, if you're a new viewer to my channel, kindly subscribe my YouTube channel and click on bell icon so that you will get a notification when we upload a new video. So guys, let us start the video, CAN protocol and its registers. So guys, one important thing what you should know about the CAN protocol registers, if you want to develop any program, if you want to develop a program on a CAN, or if you want to develop your own program for CAN protocol, it is must and should to know about the registers. If you don't know what are the registers, or if you don't know how to program them, then it is not possible to develop a program for your CAN protocol. So this video is completely CAN protocol and its registers. Let us start the video. So guys, so currently whatever you're seeing on the screen, there are plenty of registers available in the CAN. So very important, I have a very important registers I have taken here. You can see this is called as a mode register. This is one of the important register. Then we have command register, then we have interrupt enable register, and many more are there. I will show you one. So guys, a complete register set in a CAN, it is divided into three parts. So currently whatever you're seeing on the screen, so complete registers which are available in the CAN, it is divided into three parts. One will be common register. These common registers are going to be configured both in a TX and RX. That means transmitter side and receiver side, both side we will do the configuration. And second set of the register, you can see here, CAN TX register. That means very simple and straightforward. The registers which are available in the transmitter side, and similar to that, the registers which are available in the receiver side. So totally the complete register set are classified into three parts. One is a common registers between transmitter and receiver, and one is a transmitter associated register. Next one is a receiver registers. Like this it has been divided. Now one by one we will see. You can see the definition. The first one in the common registers, you can see the first one is called timing register. Okay, so in this timing register we are going to configure our baud rate value, bit rate value, time segment value. Okay, I will show you here one by one. So first one, let us take this. So CAN1 BTR, and so this is my user manual. This is a LPC 1768 user manual, as I told you. So chapter number 16 you can see here. So this is my CAN chapter. You can go here and search for this register. Just you can search it. You can see this is called, just do it once. Yeah, so this is CAN BTR. BTR stands for bus and timing register. What is the full form of BTR? BTR stands for bus and timing register, or bus timing register, you can say. So in this bus timing register, we are going to load the clock divider value. You can see here, this is called BRP. BRP stands for, it's a baud rate prescaler register, and straightforward you can say it's a clock divider. This BRP is nothing but it's a baud rate prescaler value, or it's also called as clock divider. This is the first important thing. Second important thing, in this register you can see the second bit field SJW. SJW stands for synchronization jump width, which is going to be very useful in order to achieve the synchronization. Similar to that, we have TSEG, that means time segment 1, time segment 2. These two are used in order to achieve the proper synchronization in your CAN protocol and its CAN protocol receiver and transmitter. How to do this I'll explain later in the next video. So this is called first one, bus and timing register. Next one, let us go here, mode register, CAN mode. I'll go back here and search mode register. You can see here, this is called CAN mode register. Under this, CAN can be operated in a different operating mode. You can see here. So bit number, you can observe one by one. So one is called our normal operating mode. You can see here the first bit number 0 is responsible for normal operating mode. Bit number 1 is responsible for listen only mode. Similar to that, we have self-test mode, and then we have local priority mode, and then sleep mode, and then we have active high and active low. Okay, like this the mode register is going to define the different operating modes of your CAN. So this is the second register you should know. Then CAN sleep clear. You can see here the third register is called can sleep clear. So straightforward. This is also can sleep clear register. This is very straightforward. Whenever your can is in a sleep mode, in order to wake up that, we will use this register. The can's bit 1, you can see the bit 1, it says about can sleep status register. Okay, for can 1. So assume we have two cans here. So this bit number 1 talks about can 1 sleep and the can 2 sleep. Okay, so this is the register in order to check. It's a kind of status register. It's a clear register. Whenever your can is in a sleep mode, you can clear this and you can enter into active mode. That's called as a sleep. And then so we have command register here. Let us go to that command register. And in this command register, we can select different transmission buffer. You can see here STB stands for select transmission buffer 1, select transmission buffer 2, select transmission buffer 3. Like that, the can command register is used to select the transmission buffers, and also it is used in order to release the buffer. In the receiver section, this command register is used as a release buffer. Okay, that's called as a command register. Then we have important thing called as a global status register, GSR. Let us look that. So next one is a can global status register. So this register you can see here. So this is receiver buffer status, data overrun, transmission buffer status, transmission complete status, and then we have different errors. You can see here error counters, TX error counter and RX error counter. So this GS global status register is used for checking the errors and also checking the status. Okay. Next, interrupt enable register. If you want to enable any interrupt, you can use this register. Can IER. The can IER is used to enable the register, enable the interrupt. You can see here receiver enable, transmitter enable, and it goes on like that, and error warning like that. So interrupt enable register is used to enable the interrupt. Then ICR, next one is called as ICR. ICR stands for interrupt capture register. Okay, so this is going to capture interrupt. You can see here can 1 ICR. So can 1 ICR stands for interrupt capture register. So what any type of interrupt, if it occurs, or any type of errors, this is going to capture. Okay, you can see here the reset, then transmit error interrupt, receiver error warning interrupt, and it goes on. So name itself says that can interrupt and capture register. This is going to capture the interrupts and errors. Okay, next one, error warning. So this is not required. Now let us move to the TX side. In the second section, you can see we have TID. So what do you mean by TID? TID stands for transmitter ID. Okay, so transmitter ID means you can load the ID here. So TID, what do you mean by TID? TID stands for transmitter identification register. So in this identification register, you can load the message ID. Okay, so this is called TID. Then we have TFI. TFI stands for transmission frame information register. TFI stands for transmission frame information register, and this TFI, or a transmission frame information register, it is going to define DLC, it is going to define RTR, and it's also is going to define IDE. So three important information is going to be configured in this. One is called DLC, one is called RTR, and one is called IDE. Okay, that is called TFI, transmission frame information register. Then can 1 data register A and data register B. So you can see here the data register, very straightforward definition. Data register, this register is used as a data register. If you want to load any data, you can load it. You can see here data byte 1, byte 2, data 2, data 3, and data 4. Similar to that, in the bottom you can see data register B. You can see here data register B. Here you can load byte 6, 7, and 8. So like this in the TX you can use, and similar to that RX we have. So RX in the receiver part. So here you can see this is called RID, that stands for receiver identification register. So here also you can receive 11-bit ID and 29-bit ID. Similar to that we have receiver frame status register. Frame status register. This CAN receiver frame status register is used to receive the status information such as DLC, RTR and IDE again. Similar to it is a transmission frame status, transmission frame information, but in the receiver section it is called as receiver frame status information. Okay, similar to that. So we have CAN data register A, data register B. So that also we will check it. Yeah, now you can see CAN1 RDA, that stands for CAN receiver data register A. Here you can receive a data byte, data 1, data 2, data 3, data 4. Similar to that, CAN data register B, data 5, data 6, data 7 and data 8. Okay, so these are all very important registers which are very useful in order to understand the programming. Okay, so if you're familiar about these registers, it is very easy to understand the program, or else it's very difficult to understand the program. Okay, so I hope this video is an informative video. So if you have any questions or if you have any doubts, please write it in a comment section. I'll try to answer your questions. Okay, so with this I just want to end my video here. We will meet you in the next video. Thank you.